branch.
This conference will now be recorded.
Artificial intelligence is a branch of computer science dealing with simulation of intelligent behavior in computers. Artificial intelligence can handle large quantities of data and process it quicker than human minds. AI system can handle tons of data and process it much faster. Data analytics can benefit largely from AI and machine learning. Suppose Google Analytics has analytics intelligence which uses ML to help websites faster. You can ask analytics a question in English and it will give you a prompt reply. AI provides webmaster with smart list, smart goals, conversation probability. AI helps the webmaster in improving the results of their sites. AI application predicts outcomes from the data. AI makes more accurate predictions of customer behavior, preferences, and priority. With AI, marketers can use services to build buyer strategies. Biotechnology is another field using AI to design microorganisms for industrial applications. Cybersecurity is benefiting from AI. As organizations are transferring their data through network and cloud, threat of hackers is become more significant. Cognitive AI is an excellent example of this particular field. It detects and analyzes threats and provides better decision making. Another field is fraud detection. AI helps in detecting fraud and helps organization and people in avoiding scams. Recurrent neural networks are capable of detecting fraud in their early stages. It can scan large transactions and classify according to their trustworthiness. By identifying frauds, organization can save time as well as resources and money. Another example of AI is Eve, which is AI-based robot. It discovered an ingredient of toothpaste that can cure a dangerous disease like malaria. The transport sector has been using AI for decades. Aeroplanes have been using autopilot in air since 1912. Ships and aircraft airspace also use autopilot to help them maintain the correct course. Another area where future scope of AI is quite abroad is driverless cars. Self-driving cars will be free from human errors. 90% of the traffic accidents are free from these particular errors. Many companies like Tesla, Uber are developing these particular vehicles. AI has found a special place in homes in form of smart home assistants. Amazon Echo, Google Home are popular smart home devices that let you perform various tasks using your voice commands. You can use the smart assistants for various tasks as playing a song, asking a question, buying online, opening an app, etc. You can order groceries, play music, switch on and off the lights with voice commands. Voice recognition technologies, results of artificial intelligence and machine learning. Apple Siri and Google Assistants are great examples of this particular sort. The medical sector is also using this technology for its major advantages. AI is helping medical researchers and professionals in numerous ways, enormous ways. For example, the Night Career Institute and Intel have made a collaborative cancer cloud. This cloud takes data from the medical history of the cancer patients to help the doctor in making a better diagnostics and decision making. Preventing cancer from moving higher stages is its most effective treat at this particular time. UK's National Health Service uses Google DeepMind platform to detect health risk in people. Wrong diagnostics are the significant problem in medical sector. AI helps doctor in avoiding errors by providing relevant databases and recommendations. It analyzes patient databases with similar symptoms. Earlier similar symptoms which are available in the databases and suggest a treatment with the successful cases. And we'll see some of the COVID-19 developments using AI in current pandemic. Blue Dot, an AI-driven algorithm, not only successfully detected the outbreak of Zika virus in Florida, but also spotted COVID-19. Hust and Tonji Hospital in Wuhan, Hubei, developed AI diagnostic tools that can quickly analyze blood samples to predict survival rates of COVID-19 infected patients, which is 90% accurate. In Wuhan, AI diagnostic tool is used to distinguish COVID-19 from other types of diseases in seconds by analyzing patients' chest CT scan images. AI improves early diagnostics, isolation, and treat, thus contribute control of epidemic. COVIDNet, a deep learning model, is designed to detect the COVID-19 positive cases from the chest, X-rays, and accelerate treatment from these who need it at most. Several AI-based computer vision programs deployed in China as well as throughout the world to check the patients and to check the crowd of the patients across the world, to scan crowds for COVID-19 symptoms and monitor people during the lockdown. AI-powered autonomous service robots and humanoid robots, Cloud Ginger, are used in hospitals at Wuhan. It is used to assist the healthcare workers to deliver the food and medicines to the patients and entertain the patients during the quarantine period. With these few words, I thank our director, our HOD, sir, for giving me this opportunity to conduct this fourth FDP program in NIT Warangal. I thank you very much for giving me this opportunity, sir. Thank you. Now I request our HOD, Professor Radhakrishna Garu, to address the participants.
Thanks, Raju. Respected Director, Registrar, Deans, Professor Sunil Varara from University of Salford, UK, and my colleagues from the department and participants. Good morning to all of you. At the outset, I congratulate Dr. Raju Bukia conducting series of FDP programs on behalf of our department. Actually, during this lockdown period, we have about 6 FDP programs from the department. Out of that, 5 were coordinated by the Raju Bukia, and this is the 4th one. And the kind of effort that he is keeping in organizing this kind of online FDP programs is well noted. So I welcome all of you for this ATAL Academy sponsored 5-day online FDP program. Yes, it is organized by the CSC department of NIT Warangal. And as some of you may already aware that our department is serving as a hub of innovative teaching and research, and a lot of faculty members are going for the teaching this AI and machine learning subjects, and then they are active researchers in their respective domains of expertise, and also leading various projects within the department. And we have a very good number of sponsored projects from the Ministry Government of India. So our director also gives us continuous support and always encourages us. They always says that his quality is the main criteria for success. So under his guidance, the department actually started few labs recently, like a big data lab, security lab, IoT lab, machine learning lab, kind of things. So, and our students are well equipped with the fundamental concepts of computer science, because that is the basis for any of the computer science professionals. and we also make them to be trained according to the today's industry needs. And you can see there's a lot of changes happening in the industry, right? So, and we are actually focusing, most of our faculty, we maybe seen that 80 to 90% of faculty are core research areas are surrounding around the AI and ML things. And we also provide the exposure to real industry problems, because that will make them the students to have a industry readiness and also prove them as a thought leaders in the future. Coming to this topic, as our the FDP coordinator already explained you that there are a lot of benefits of this one, and you can look at the overall AI landscape, which was the computers itself started for the more automating the business processes, where each business process is having a set of tasks. Right? And then the other extreme is now we are talking about the artificial intelligence, where we want to incorporate intelligence in the form of a in each and every task of a business process. So that's why the embedded AI is the one of the basic things which most of the organizations today look into it, because they want to say that on their systems are what are the solutions they develop, they are covered by the AI. Though the initial term of the intelligence was termed by the Alan Turing, but later John McCarthy coined this term AI in 1956. But thereafter, the AI has faced a lot of downfall. But of course, we leave that dark area of AI. But in the recent past, the AI became the buzzword, and not only in the industry, but it's also in academia. And today, most of the institutions like IITs also started in the BTech programs in specific to AI area. And AI-based systems are now almost used in every part of the life. And the humans are getting a much significant improvements, and also increased efficiency in almost all kinds of applications. And today, all the bigger vendors like Amazon, Google, Microsoft, Facebook, so all these people, the kind of developments they're making every day, you look at the lot of research papers which they're publishing it, and the kind of solutions they're developing it. Even recently, maybe a year back, Facebook has launched the fast search algorithm with that is a very good algorithm, isn't it? And then Microsoft launched the cognitive AI technologies platform, and Google launched Google Cloud Vision API. So there are many ways that there are a lot of tools and technologies are available. And today, the libraries provide us our life will be much more easier to use these new kind of technologies. So that's why the AI is not like a one kind of area. There are a lot of new areas also emerging and maybe participating in the AI part of it. And one of the things today, people are looking like AI, machine learning, deep learning, this kind of a terminology. But the other disciplines like psychology, people are wants to make those disciplines also part of the AI. And now they are trying to please even the robots also. Right? So as the development of AI continues grows, and then it will change the ways we live and work more and more. So that's why now let's see which areas of AI will have a huge impact in 2020. As I already mentioned that there's a COVID-19, people are working, they want to use a lot of these deep learning algorithms to identify the kind of patterns that can generate from the this COVID data, right? And then of course we always face this AI chatbots and right, and then smartphones, cameras, each and every device is becoming like intelligent. Maybe we will see in the future there is AI will become more smarter than the humans also. So once again, I welcome you all for this wonderful program of 5-day online program. And this 5 days you can learn a lot of aspects which this good syllabus was prepared for this FDP program. And I thank you again for the Raju Mukhya for organizing this one. Thanks, and I wish all the best. Over to Raju.
Thank you, sir. Thank you very much for your valuable speech. Now I request our beloved director to address the participants.
Very good morning to all the participants. Professor P. Radhakrishna, Head of the Department of Computer Science, Professor Sunil Vadera, University of Salford, United Kingdom, Dr. Raju Mukhya, the coordinator of this program. And at the outset, let me extend a very warm welcome to all the participants and the guests for this ATAL program on artificial intelligence. Most of you are aware that the AICT ATAL Academy, that is the Academy of Teaching, Training and Learning, has started unique faculty development programs to train a large number of teachers, especially in thirst areas. And I'm glad to inform that NIT Warangal has received 8 such projects out of the 83 FDP sanctions throughout the country, and some more are in the pipeline. So all these things are in the online, and we all understand that this online facility, in fact, we are passing through the most difficult times, and the present need is to adopt innovative measures as per the exigencies. So the regular mode of teaching and learning has come to a standstill. Anyway, we are all today, because of that, we are attending through online, sitting at our comforts of homes. We all realize that these are extraordinary times and require extraordinary efforts by one and all. And I hope that after going through this course, you will go back and mentor your other faculty and students, and the students will get benefit. So this ATAL Academy through online courses has given us an opportunity for us to learn from anywhere, anytime. And I'm glad that Raju Bhukia, I think this is the 4th in the series. He has one more to complete, and we have some more programs in the pipeline. I'm sure you'll all participate, but I should at this time I should acknowledge that AICT has really identified thirst areas like artificial intelligence, Internet of Things, blockchain, robotics, quantum computing, data sciences, cyber computing, 3D printing and design, and unmanned aerial vehicles and other techniques, nanosatellites. So these areas are really of great importance. And today, our students need expertise in this area by a blend of both offline and online. And since COVID has prevented us to make it offline, impossible for offline, so we need to train teachers and students in this online field. And I'm glad that even in this pandemic period, our Department of Computer Science is facilitating continuous and uninterrupted learning to all the faculty and students. I was told that there's a large response to this particular course, but due to restrictions imposed by the organizers, we have restricted the number of candidates. And the topic that is chosen, the artificial intelligence, as informed by Raju Bhukia, it's a very important area. And even just 2 days back, IIT Hyderabad has come out with a testing with the help of artificial intelligence methodology. The beauty of that testing is it costs very, very less, affordable, and you can test large number of people and you get the results very fast. So that is how artificial intelligence has made our life difference. Today, we all realize that the amount of data that is generated by both humans and machines far outpaces humans' ability to absorb, interpret, and make complex decisions based on that data. And that is where artificial intelligence forms the basis for all computer learning and is a future for all complex decision making. AI today has been used to develop and advance numerous fields and industries, including finance, healthcare, education, transportation, and many more actually. So we all realize that the advantages of using artificial intelligence, it helps us for error reduction and increases the chance of reaching higher accuracy with a greater degree of precision. So today, it can be applied in various situations, including the process called exploration of space. That is also another area. I'm sure the speakers, especially Professor Sunil Vadera, will cover many other topics. And this is actually a 5-day program. And all the faculty who have come from different institutes throughout the country will get benefited. So please make use of this opportunity and try to see that you get the best out of this. And I also take this once again, this opportunity to propose, to congratulate Dr. Raju Bhukia, who has been very active, and he will be conducting many more online courses under the head of NIT Warangal, because he has really taken over as a head of online courses, and I'm sure many faculty will come back to us for improving their knowledge. And with these few words, I once again thank all of you for making it convenient to attend this FDP. So thank you very much, and thank you all for your kind attention. Thank you. Over to Raju Bhukia.
Thank you, sir. Thank you very much for your valuable speech. Actually, for this workshop, we are having 3 international speakers, like Professor Sunil Vadera from University of Salford, and Zhang Dong from UK, and Shivakumar from Santa Clara University. 3 professors from the international speakers we are having for 3 days. I thank them for giving us a very good opportunity in this particular ATAL workshop. Thank you, sir. Now I request our chief guest, Professor Sunil Vadera garu, to address the participants.
Good morning, everybody. It's my real pleasure to have been invited to this event. I have links with Warangal. Some of you may not know that in 1997, I visited what was then REC Warangal. So I'm grateful, Dr. Ramana Rao, Dr. Radhakrishna Rajapukya, for this kind invitation to connect with you again after so long. In '97, I was part of an ODA program, a British Council program, and funnily enough, the workshop I gave was labeled Artificial Intelligence. So it's a real pleasure after so many years to visit online a place that I had fond memories of in 1997, and on a topic that I'm really passionate about. I'd just like to say a few words. First of all, I hope you're all keeping well in this pandemic. It is a difficult time for everyone, and I'm pleased to see that that online sessions like this are taking place and keeping everybody interested and busy at a difficult time. I'm sure that's the case also for all the students at NIT Warangal. This is the third wave of artificial intelligence. Like most research fields, things go up and down. The first wave was based around connectionism and was dampened down by claims that neural networks can't do much, by a famous work by Minsky and Papad. In the 80s and 90s, we saw a second wave. The second wave was driven by something called expert systems. So these were rule-based systems mainly, that people could encode expert knowledge, and that worked to some extent. People soon realized that there was a difficulty in extracting information from experts, whether they're civil engineers, whether they're medical people, or whether they're space scientists. It wasn't easy to get them to explain how they arrive at decisions, and therefore it was difficult to encode something that you can't extract from people. We're now in the third wave, the machine learning wave. The machine learning wave, of course, has been driven by advances in deep learning, image processing, and those advances have arrived over the last decade, mainly because of a competition, the ImageNet competition, and mainly because of the wide publicity given to the kind of application that Dr. Rajapukya articulated earlier. Many potential applications, very few actually fielded applications that have made a big difference. A lot of research, but the fielded applications have been mainly via Microsoft, Google, and the like. The third wave has the potential of going the same way as the first and second waves. The second wave declined for a good reason. And the third wave could also decline unless we are able to address some of the challenges, some of the real challenges. If we take accuracy, most machine learning algorithms focus on maximizing accuracy. But in actual fact, most machine learning algorithms to be applied should focus on the cost of misclassification, or the impact, if not the cost, the impact of classification. If you just focus on accuracy, let's take something simple like fraud detection. 99% of the cases that you have might be fine, might be okay. 1% might be fraudulent. If you want a simple algorithm that gives you 99% accuracy, you simply say everything is fine, you have 99% accuracy. But the 1% might cost you a lot. Take that example, translate it to COVID. If the proportion of people that get COVID is small, the overall accuracy of an algorithm might be high, but actually the impact of getting it wrong, the impact of false negatives, cost lives. So there's one example of what could potentially go wrong with straightforward machine learning algorithms. If you take convolutional neural networks, it's very difficult to provide explanations. It's very difficult to be assured that the decisions that it is reaching are transparent and can be justified in medical terms. So what I'm getting at is this third wave requires some thinking, some careful thought about the impact of the applications and whether those applications will work in the real world when it matters most. This is where you, as delegates of a workshop like this, have a role to play, because you are the drivers of the technology. You and the students of the future are the drivers of whether this technology will achieve its full potential. To achieve its full potential, what we need to do is educate the next generation so that they're not only technologists, but they're multidisciplinary agents who understand that it's not just about writing programs, it's not just about publishing papers, it's about making sure that technology is able to translate. Now, translating that technology means thinking about fairness, for example. Are our systems fair? Will they make sure that they do not discriminate? At the moment, there is obviously a lot of protests about racism. It turns out that some of the machine learning algorithms that we use have an inbuilt bias, a bias against certain characteristics, for example. So there are examples in the UK where a research team has tried to develop a system that filters applications for jobs. And following a prototype and some testing, they realized that it discriminated against females. There are other examples in policing in New York and in the States, where people have tried machine learning algorithms to predict hotspots of crime. And again, people have found that the output from the machine learning algorithms are twice as likely to suggest that a black person is a suspect compared to a white person, and do that unfairly. So again, the message I would like to get across to you is that you have to think about what happens when your algorithm is used in practice, and make sure it doesn't discriminate, and make sure it is fair. And that requires some scientific thought. The methodologies that you use to assess the algorithms have to take that into account. You can't just say, here's a training set, a testing set. I push my testing set through the algorithm. I get a confusion matrix. I get an accuracy. Accuracy is 95%. My algorithm is better than another algorithm that was published in this particular year. That is no longer enough. We have to move to the next stage of machine learning research, which does, as Dr. Rao said, it does mean multidisciplinary work, talking to other disciplines who understand their field of application better. So I'm going to conclude by once again congratulate you on congratulate Raju Bhukia, congratulate REC Warangal on what is, I hope, and I'm sure, a wonderful workshop that will ensure that we educate the next generation of AI researchers. Thank you.
Thank you, sir. Thank you very much for your valuable speech. Now I request Vadera sir, Professor Vadera garu to hand over the session.
I'm pleased to hand over the session to you, Dr. Raju Bhukia.
Okay, sir. Thank you. The session will begin in 10 minutes.
Okay, thank you.
Okay.
Sir, can you start your sentence?
Okay, can you hear me?
Yes, sir.
Can you
Yes,
hear me?
audible, sir.
Okay, thank you. So I will start my presentation. Once again, thank you for inviting me to give a talk at this workshop. The topic I'm going to present is called Nonlinear Cost-Sensitive Decision Tree Learning. My research is currently focused on this topic of cost-sensitive decision tree learning, but also on deep learning and neural networks. I thought I would present something on cost-sensitive decision tree learning because there is already a lot of work and presentation on deep learning in the field, and to remind people that this is an important topic where research needs to continue. I'm going to first of all motivate the talk, give you some an overview of key research, and then the emerging questions, and then briefly talk about 3 new algorithms that we've been developing at my university.
Sir, not audible, sir. Your mic is
Can you please unmute?
Hello, can you hear me?
Okay, sir. Okay. Okay, sir. Okay.
Let me just, do you want me to start again? Okay, I'm going to start again. I'm not sure whether people heard
Yes, sir.
me.
Yes, sir. You can.
ఇంకిప్పుడేం చేయలేదురా
Hello?
ఇంకిప్పుడేం
Sir, you can continue your sentence.
Okay, we'll continue. So what's the problem, and is it worth solving? The problem is that you take some training data, you use the training data to learn how to take a decision. So for example, you take training data about presentations and whether to attend a presentation or not, and you might get a decision tree like this. Is it an interesting topic? If it is, if it isn't, then don't attend. If it is, and you have time, then attend the talk. Otherwise, if you don't have time, don't attend the talk. So you can imagine that's easily stated as a problem. Maximize the accuracy of the classification given some test data after you've trained on the training data. In terms of motivation, over the years, I've been involved in a number of live applications of this technology of decision tree learning. One of the applications has included what's known as subprime lending, where you do some credit scoring but the credit scoring is for people who can't afford large sums of money and whose credit rating might not be great with the banks. So here's the application. In this application, we were trying to develop a system that would lend to people who had low credit scores. So
birthday as well today. I'm paying off debts on my birthday, getting a loan on my birthday. I mean, it's nice. Moneyline started about 10 years ago to tackle financial exclusion in a particular borough. A typical customer would generally be a young woman living in social housing and will have multiple dependents and basically living wholly and partially on benefit and managing their finances largely week to week. We got involved with the University of Salford because we already had quite a long-standing relationship with Professor Carl Dayton, who works in financial inclusion. He suggested we meet up with the School of Computing and Science because they were looking to run what's called a knowledge transfer partnership. We knew we had this kind of bank of data that we collected over a period of time for all our customers, and we wanted to put it to some use to try and analyse were there any patterns in that data that might predict the risk of lending to certain types of customers.
I work mainly in the field of data mining. Data mining is a field where you look at
where our customers are largely operating outside of that. They're mostly dealing in cash, and they're mostly not really making full use of the bank account because they only really have access to a basic bank account. A lot of people have got themselves into a lot of difficulty now there, the joint debt lenders and VIP lenders. Typical customers coming in with loans outstanding of £500 average.
Use data mining, use the model.
To actually have the confidence to expand into more geographical locations. We ultimately want to make the business national, and it means more people who wouldn't necessarily have had access to the service will have access to affordable finance.
One of the big benefits of the university has been that it's brought together people from the social sciences side and the science side in a multidisciplinary project, taking account of social factors as well as hard objective factors, and providing solutions that a single discipline on its own would have been unable to provide.
It's access to knowledge that we wouldn't have internally, and we can use that knowledge to develop the business.
A lot of them want stores. They charge about like 9.99.
We're really pleased that the models we've developed has enabled a more consistent approach to lending in a way that helps people who would not normally get loans from banks, people who probably need the money the most, and people who would otherwise struggle.
I don't know where to be without you.
Okay, so I skipped parts of the video because I wanted to get the message across that you can have successful applications of decision tree learning. And that was one successful application which helped a company provide small loans to people who couldn't normally afford loans. So that's a success. Let me talk about a failure. What motivates research are successes and failures. Failures provide the challenges. So here's the key motivation in terms of a failure. In the 80s and 90s, there was the second wave of AI led to expert systems which helped people use systems, advisory systems. In the UK, there's a body called the Health and Safety Executive, and they approached us to develop a system called Dust Expert for explosion relief in chemical process plants. So these explosions are a little bit different from the kind of explosion that was in Bhopal, which was an exothermic explosion. These explosions happen in chemical process plants, flour processing plants, furniture plants. There's an image of one particular explosion that happened some years ago. And what they try and do is to reduce the chances of an explosion. So we developed an expert system that helped companies mitigate explosions to decide whether a plant is safe or not. What they then said to us was that they had some near miss data, and they asked us, can you actually learn the rules for near misses? We applied standard neural networks, we applied decision tree learning, support vector machines, and the usual methods that people use these days. Unfortunately, the methods fail because they focus on accuracy. Although the accuracy of no explosion is high, the number of times it fails to detect when there's an explosion or when there's likely to be an explosion is low. So the false negative rate is actually very poor. So what you need in problems like this is an inclusion of the cost of misclassifying. So you need to take account of the cost of a plant being unsafe. So we did that, and that really motivated the work that we were doing. So if you want to go beyond accuracy alone, you need a usual confusion matrix. So in this example, we've got a confusion matrix which records the number of times something is predicted as unsafe, is actually unsafe, and incorrectly predicts a plant as safe. Likewise, if the algorithm predicts safe, but it turns out that it's unsafe, then you have 100 cases of it being predicted as unsafe, as safe when it's actually unsafe. Not only do you need a confusion matrix, you need a cost matrix. You need a cost matrix like this, where I'm having troubles with the screen at the moment, but you need a confusion matrix like this, where you include the costs of misclassification. Once you have a confusion matrix like this, what you can do is you can take the product of the corresponding elements. So you'd multiply the corresponding elements to get the expected cost. That's great. So what you can do is you can work out the expected cost. So that's 220 times 0, 10 times 10, 100 times 100, 200 times 0, and divide by the number of cases to get the expected cost. You also need the cost of tests. So in most machine learning algorithms, you tend to forget that in practice, tests cost. In this particular application, you need the cost of inspecting the plant, you need the cost of testing the material to see how explosive it is, and you need a structural engineer to test the weakness of the plant or the vessel that includes the materials. Once you've got the cost matrix, the confusion matrix, and these costs of tests, your task is to minimize the average cost. And the average cost is simply, as I described before, the multiplication of the corresponding elements of the confusion matrix with the cost matrix, and then the addition of the average cost of the tests that you've got. How has this problem been tackled? Some time ago, we did a survey of methods for cost-sensitive decision tree learning, and there are actually over 50 algorithms that have been developed for cost-sensitive decision tree learning. The first one started a long time ago, and the very first decision tree algorithm started as far back as 1966, with the first major development being in 1979 by Ross Quinlan. Now that algorithm is the one you teach in most AI courses, and is an algorithm that is used as the core for most of the systems available today. So if you use things like scikit-learn or MATLAB or the Weka toolkit, and you use the decision tree algorithms in those systems, then you'll be using an extended version of the algorithm that was developed as far back as 1979 by Ross Quinlan. I'm going to introduce you that just as background, and then I'm going to talk about some of the more recent advances in the field all the way up to today. So let me introduce you the core idea of decision tree learning, either as revision or as motivation and as something that's new. I'm going to introduce you the algorithm with the aid of an example. Suppose you want to design a system that decides whether to invite a student for an interview for a position as a programmer. You collect some examples, and these are the examples, a small number of examples just for illustrative purposes. So the first example is somebody who's good at programming, is okay at communication, is neat, and is invited for an interview. The second example, likewise, is somebody who's average, okay, fair, and is invited. The third one is somebody who's a poor programmer and is not invited for an interview. So how does the decision tree learning algorithm work in this situation? Well, it first of all selects a question. So suppose you choose presentation. Presentation has got three possible values: neat, fair, and scruffy. If somebody's neat, they fit under the first category there, and there is only one example like that. And that example has the answer yes. That has the answer yes. For the fair category, you've got examples 2, 4, and 9. And for the scruffy category, you've got the remaining examples. For the fair category, you would have noticed that examples 2 has the answer yes, example 4 has the answer no. So there is some disagreement. Because there is disagreement, you ask another question. So you ask another question and you repeat the process. You repeat the process going through. So if you repeat the process, you get this decision tree coming out. Once you've got a decision tree, the important thing about this decision tree is that you take all the examples and you drop them through the tree. So you haven't lost any of the examples that are there. Because you haven't lost any of the examples, the answer you will get will be consistent with the table of examples that you've got. At this stage, you'll have a question. The question is that I chose presentation as the first question to ask. Why not choose another question? So you can choose another question, you get a different tree. So in this case, notice that if the presentation is neat, the person is invited for an interview. So what happens if you choose a different question? Suppose you choose programming as the root of the tree. You get this tree coming out. It's a different tree that you get. You still use the same top-down procedure where you take all the examples, you drop them through a step at a time in a top-down way. So when you do that, you get this tree coming out. And in this tree, notice that if programming is poor, the person is not invited for an interview. Learning is about taking a new example. Suppose we take this new example and see what happens. So this person is neat, a poor programmer, and a liar. So if we use tree 1, what do we get? Because the person is neat, the tree says yes. If we use our second tree, where we use programming, because the person is a poor programmer, we get no coming out. So we have a problem. We have two trees. Both trees are consistent with the training examples. So both trees correctly learn the training examples well, but unfortunately the trees give a different answer. So you get a different answer coming out. Which tree is better? Well, which one do we choose? Well, this problem was tackled by Quinn Lan, who said what you can do is use information theory to select the right question. So here's our example. You've got communication ability and programming. How do you use entropy to select the right question? Entropy gives an indication of the amount of disorder in a system. So if we were to choose this as the division, we still have a lot of entropy here in the top panel, and you still have a lot of entropy here in the bottom panel because you've got a mixture of crosses and ticks, and it's not clean. If instead you use this as the divisor, you have a clean set of values here and a clean set of values here at the bottom panel, and as a result the entropy is less. You still have a mixture of crosses and ticks here, so you still got some entropy there, but you can reduce that entropy by having a line there. So entropy gives you a measure of the amount of uncertainty left in the decision making, and you can then use this measure which is defined as the entropy. It's based on the probability of an event, because the probability determines how much information you get. So if the probability is low, the amount of information that you're going to get is high. If the probability is high, the amount of information that you would get by making that division is low. So using that measure, you can work out which attribute to select or which question to select. And if you do that, you're able to produce this tree instead. And this tree is better. Turns out that empirically, using that idea of entropy or information gain to decide which question to ask is better. So that's just a brief introduction and a reminder. I'm going to move on to the research on cost-sensitive learning now. So how can costs be included? So the first set of algorithms adapted that measure. So if you were asked to do some research in this field at this moment, you would probably just go back and say, okay, this measure of information doesn't include the cost. It includes the probability of an event, but not the cost. So if I want to make it cost sensitive, all I would need to do is put the cost measure there. So the first sets of research that was done here in the 90s took the measure and added the cost. So here you can see that that's the information gain measure, and what people did was add the cost, divide by the cost at the bottom. Once they've got the measure in, you just use the same algorithm in the procedure that's there. Unfortunately, this didn't work, so people then moved on to using genetic algorithms. So the next big algorithm that was developed was called ICE-T. The ICE-T idea is as follows. So this paper has been cited many, many times, over 900 times over the years. So the idea with ICE-T was to use a genetic algorithm, but the genetic algorithm includes chromosomes, where each chromosome has genes, and the genes used were the weight, omega, the cost, and CF. CF is the pruning factor in decision tree learning that is used, that's there. So this is the measure that's used in the EG2 algorithm, and that's the individuals in the genetic algorithm, in the population of the genetic algorithm. So each of those is fed to an existing algorithm called EG2, and each of those produces a decision tree. And then using the idea of a genetic algorithm, you evaluate the fitness of each of those trees. You do the usual mutation crossover operators, and you repeat the process going through this loop here. Once you've repeated that, say 50 times, 50 iterations, you can produce the fittest algorithm that's there. And that's the idea that was used by Turney and Ice-T. Unfortunately, the results weren't particularly good because it was difficult to identify a patient as sick. So because of the imbalance in the data set, it was difficult to identify a patient as sick. So moving on to the next big innovation in the field was metacost. The idea with metacost is to use bagging. If you're not familiar with bagging, bagging is like committee voting. So what you do is you take the views of different members of the committee and then you aggregate their views to produce the decision. So what Dominguez did in 1999 in developing metacost is to say, I'm going to generate n samples. Each sample of the data is thrown to the machine learning algorithm. That then produces the decision trees, and then you combine the results. But unfortunately, just combining the results doesn't produce a single decision tree. So what Dominguez did was to say, okay, I will take the results, I will relabel the data, and then I will reapply the decision tree learning algorithm, and we will get a final tree coming through. Okay, so that gives you a flavor of past research in the field. The important thing, as Einstein said, is not to stop questioning. Don't accept the fact that they all work. Curiosity has its own reason for existing. So my message is, don't accept that existing algorithms work well always, and you need to develop new ones. So what's the issue with the existing algorithms? Well, the first issue is that the Ice-T algorithm uses biases. If you take your favorite machine learning toolkit, say Weka or MATLAB or scikit-learn, and you use the decision tree learning algorithm, it gives you what are known as parallel splits. Why use parallel splits? Is it possible to use good trees without first generating many trees? Do you have to use top-down algorithms? So let's answer the first question. So this is the way Ice-T works. I've just described how that works. So taking a quote from Albert Einstein, everything should be made as simple as possible, but not simpler. So if we take this algorithm, which uses another program to generate the trees, what's more complex? To simplify this, you can simply cross off these two parts. Why use biases? Why use another algorithm? Why don't you just represent the trees directly? Okay, why don't you take the algorithm, genetic algorithm, represent the trees directly? So that's what we did. We developed an algorithm that represented the trees directly and is able to induce the trees directly. So the idea is to take individuals in a genetic population and view them as trees. So we encode decision trees as bit patterns, and then you can generate the trees in that way. The fitness function of the genetic algorithm is just the expected cost. So once you've got that, you can just do the same thing and you get good results. You get better results than Ice-T. So here's a graph of the initial results that you get. That's the average cost on the y-axis. On the x-axis, you've got the misclassification cost ratio for a two-class problem. And the black line is the cost result from Ice-T. The pink line is the result from the new algorithm that is simpler and quicker than the original Ice-T algorithm. When we first submitted this paper, people pointed out that actually the cost ratios that you're using, the cost of the two classes is too large and it's not really what happens in practice. So we did other experiments. and we still get good results. So here you've got the ICT algorithm in black for the different data sets that are available. Okay, so question 2 and 3, y-axis parallel splits. So if you use your decision tree algorithm, and this is the way it's taught in your courses, suppose you give it this data set. What's the tree that you obtain? What tree do you obtain if you use this data set? Well, this is the tree you will obtain. First of all, you would draw a line there. X is below 20, that's all pink. If X is bigger than 80, it's all pink. If Y is below 20, it's all pink or red. Otherwise, it's blue. That's the tree you will get. This is the tree that you would get. Okay, that's the tree you get. So take your favorite toolkit, put that data in, that's what you will get. Surely that's not right. Surely the tree should look like this. Okay, so that's what we did next. We developed an algorithm called cost-sensitive nonlinear decision tree learning, and it's able to produce nonlinear regions. So you get a tree which has got nonlinear functions within the tree. How do you get the nonlinear tree? Well, you can do that by making an assumption that the classes might be nearly normally distributed. If you do that, you can get optimal discriminants coming out where the sigmas are the covariance matrices of the two classes. And you get this optimal rule due to Fisher. So if you use that, you can use a top-down decision tree learning algorithm. So you'll find this decision tree learning algorithm in the ACM journals. And the key idea there is to use that equation to do the split, but then to use the top-down decision tree learning algorithm all the way through. The only minor issue there is that sometimes the inverse is not available. If the inverse is not available or is not possible, then you go to the axis parallel splits. The results you get again are very good, and you can read up on the results if you're interested in the publication. So the lessons we learned from that algorithm is that you can produce better results than ICT and MetaCost without evolving or generating multiple trees. Bagging does improve the results further, and you get the results in 12 out of 17 data sets that are better. The main problem with that algorithm is it's still greedy and it's limited to 2 classes. Here's the latest work that we've been doing. Suppose you've got this data. This has got multiple classes. How do you apply nonlinear decision tree learning to this problem? This time what we said, okay, why don't you think about this differently? Why don't you think about, instead of drawing lines, why don't you say, how can we place some ellipses like this? So the task becomes, how do you place ellipses onto the data? And from that, can you produce a decision tree? So we can use genetic algorithms or optimization to do that. We know the equation of an ellipse. It's got 5 parameters, including h, k, and alpha, the angle, and a and b is the radii. So you've got the parameters, so why not evolve the tree? So that's what we did. We developed an algorithm like this, where you've got the population of the genetic algorithm consists of the ellipses, and you evolve the ellipses based on an optimizer. It can be a part of the swarm optimizer or your favorite genetic algorithm optimizer. And then you can produce the tree. Once you've got an optimization, you can produce the tree. Again, it produces good results when you compare it with existing work. So these are some of the results that you get on different data sets. And you can see that the last 2 columns, it produces good results. So I'm going to finish off now and conclude. These cost-sensitive decision trees are an important area of research. There are applications and there will be future applications of these algorithms. Producing nonlinear trees is better than greedy algorithms that include axis parallel splitting. Further research on cost-sensitive decision tree is worthwhile given the potential applications. Thank you for listening. Thank you for listening. I'm handing back over to the chair of the workshop. Hello, I just want to hand back over to the chair of the workshop, or if there are any questions. Are there any questions? Hello, are there any questions?
Hi, sir. Hi, sir. Good morning.
Good morning.
This is good morning. This is very new to myself. I'm not supposed to ask any queries regarding this. Any questions? I have required some background on this. In the later sessions, I may go for it. I may ask the queries.
Okay.
Thank you.
Thank you. Hello. Hello, Dr. Rajabukia.
Raju sir, it is not audible, sir.
Is it audible now?
Yeah, it's okay, sir. Now you can.
Okay, right.
Sir, now not audible, sir.
Hello. Is it audible now?
Yes, sir.
Yeah.
Now audible.
Okay.
Hello, Dr. Rajabukia. I'm struggling here at this end.
Yeah. Thank you, sir. Thank you for your wonderful lecture. Thank you very much for giving us the opportunity to have a wonderful session in this particular ATAL workshop. Thank you very much.
Okay. Thank you, everybody, and have a good day.
Thank you, sir. Thank you.
Bye.
Yeah. Now we will take a break. We'll take the break and we'll join at 2 o'clock.
Okay, sir.
Okay.
Yes, sir.
Yeah. We'll take the break and we'll join at 2 o'clock.
Okay, sir.
Thank you, sir.
Yeah. Manish Tiwari will be taking next session in evening. That is 2 to 4.
Okay, thank you, sir.
Same login.
Okay, sir.
Right.
Thank you,
Same
sir.
login.
Okay.
Login, the same login,
Okay, sir.
sir.
Thank you.
Login is the same.
Yes, madam. You can use the same login ID.
Yes, you have to log in with the same account.
Okay. Okay. Thank you, sir. Thank you.
Fine.
What about attendance, sir?
Ma'am, we are already GoToMeeting is recording, ma'am. Automatically GoToMeeting will record the attendance.
Okay, sir. Thank you.